and a very warm welcome to all the people attending the workshop today, organized by Analytics India magazine in association with Intel. Today, we are going to understand and learn about OneAPI AI Analytics Toolkit. To give you guys a brief background, for various compute accelerator architectures, machine learning developers often work on separate code bases, work with multiple programming languages, different tools and workflows. So usually for the same set of machine learning models, developers have to manage and write codes compatible to specific CPUs and GPUs. This definitely makes the task highly cumbersome, inefficient, and comes with challenges like hardware lock-in and the inability to reuse the code. And this is where Intel's OneAPI AI Analytics Toolkit comes in handy. It provides an open standard-based programming model that enables developers to choose which accelerator to run their software. This makes it a revolutionary framework, something which all data scientists can take advantage of. So this workshop is going to give us a better hands-on understanding of how to use this AI Analytics Toolkit. Before we delve into the session, I would request you to register yourself on Intel Dev Cloud. The link has been shared with you over the chat box. Please use the event code OneAPI 17 June. So to get yourself started with this workshop, please go and register yourself on the given link. We are also running a lucky draw wherein 15 lucky participants, registrants on Intel Dev Cloud will get a chance to win Amazon vouchers worth ₹1,000 each. So please hurry up and register yourself on Intel Dev Cloud with the event code to stand a chance to win. The workshop will run from 9:30 a.m. to 12:30 p.m. So hold on for that. And on that note, I will hand over the session to Kavita, who is a Developer Marketing Manager, APJ at Intel. Over to you, Kavita.
Thank you, Sujiti, for that wonderful introduction and insights into what we're presenting today. And thanks, AIM, for this, some awesome collaboration in bringing your audience from the AI segment to the OneAPI Analytics workshop. Well, I see some amazing set of audience today in the attendee list, and I'm sure you will have some great takeaways from the AI analytics with OneAPI, right, presented by the trainers from Intel. With this, I would, possibly take you through some of the key elements of the workshop today. Ellen, if you can view to the next slide, please. Yeah, here's some ground rules for all of us who are participating in the hands-on workshop. The prerequisite for this workshop is you have to sign up to DevCloud, which is mandatory. So the link has been posted on the chat window, as well as the DevCloud setup guide is on Discord. So sign up to DevCloud with OneAPI 17 June as the event code, and you stand a chance to win those Amazon vouchers from AI. Do bear with us on any internet connectivity today, or if there's a glitch from GoToWebinar, because we are all working remotely, and we will come back to you soon. All of the questions for the workshop today is managed on Discord. So the trainers and then the moderators are present for you on Discord to sort out any questions you might have on the AI Analytics Toolkit. So log into Discord channel. The URL has been posted on the chat window, and the format to sign up has also been shared there. If you have any questions, please text us on the GoToWaiting webinar. There are some post questions for you, so it's going to be interesting and fun. So participate throughout the session today. Okay. Ellen, the next slide, please. Okay, so we are, as Sujiti explained, we are going to run a couple of contests for you. So the very first contest is the workshop, activity. We have some judging criteria as usual for most of the hack sessions and contests. So all you need to do is submit the optimized Python code using ML and DL and an Intel optimized TensorFlow exercises that you are being shown across by the trainers during the workshop. So concentrate and participate there. You might have to send me the screenshots with the performance results before we close the day today. That is before 1 p.m. IST. If you're not, for some reason, unable to sign up to DevCloud, or if you have missed completing the exercises, you have time extended up to 5 p.m. tomorrow, which is 18 June. So send out all your exercises and the performance results to kavita.arur@intel.com by tomorrow, 5 p.m. 18 June. All you need to do is sign up to DevCloud throughout the session today, be active, as well as if you're sending these codes to us tomorrow, be active on DevCloud throughout the process of your using those modules and exercises, and send the results to me. You have a chance to win the Amazon Eco 5 show, which has a great display of 5.5 display screen and very crisp sound. So you can be a winner there, participate, and it's going to be fun and a lot of learning for you guys out there. The next contest and a little bit about the Devmesh projects. For you, if you're not familiar to Devmesh, sign up to devmesh.intel.com. It's a very cool site and forum for a community and like-minded individuals like you. We have approximately about 200 plus projects there just on OneAPI. Irrespective of the platform you're working with today, whether it's AI, IoT, game dev, or OneAPI or DPC++, right? Sign up there, share some of your amazing stories. There are a lot of innovators present on this forum there today. You can network with them. You can create your own blog articles, share them with Intel, share your amazing innovation stories with Intel, and we can give you a slot to come up and participate in some of our workshops and summits where you can share your innovation story with the fellow members. So sign up today, post the workshop, and share some of your projects on devmesh.intel.com. Okay, so we have a small contest running for the Devmesh project as well today. During the workshop, if you have learned through the modules, go back and sign up to devmesh.com and submit your project before 25th of June. So what you need to do is, if there are projects that you've used through your stock Python or stock TensorFlow, it could be replaced with Intel distribution of Python or optimization of TensorFlow or 1DL with using OneAPI components. So ensure you're using one of the OneAPI toolkits or components there. And after you replace, right, the performance you derive out of it, please share them on devmesh.intel.com along with your projects, and send us the URL. So send me the URL before 25th of June of what submissions have you done, and the top 10 entries will stand a chance to win the Amazon gift voucher. So looking for some cool projects coming up there. So participate and win. We will announce all of these contest winners on the Analytics India magazine as we are closer to the end of the month. So you will look forward for those results being shared there. With this, I'm gonna go ahead and talk about our first presenter for the day, Lakshmi Narasimhan. So Lakshmi is the technical lead for the developer product support and consulting division. And he in his role is responsible for mostly working with the developers ecosystem to help them get the best performance across IoT, client, AI, and HPC segments. And he has been working with Intel for over 16 years now and has led several organizations across these platforms. He holds a bachelor's degree in computer science and has completed his senior executive leadership program from INSEAD. In his free time, he loves to read, write, and teach in his spare time. You can engage with Lakshmi on Twitter and LinkedIn. He's good at networking out there, as well as Discord is a platform for live Q&A today. So look out for more details there. Our next presenter today is Jing San. So Jing San is a senior technical consulting in the developer product support and consulting organization within the Intel Software Group as an AI specialist. He's been with Intel for over 5 years now and has good experience in managing the global developer community, engineers and researchers, using Intel tools and high performance libraries in the area of deep learning, Fable, MPL, and 1DNM. His interest lies in machine learning, DL, performance optimization, and data analysis R&D. So feel forward to interact with him on Discord today and know more from him. Our next presenter for the day is Arithya Sarvaiya. Arithya is the AI technical consulting engineer, again in the developer product support and consulting organization at Intel. He holds a bachelor's degree in engineering physics from IIT Delhi and master's degree in computer science and AI specialization from IIT Mumbai. And apart from his work, he loves to watch and play football and cricket. So we have all these three, core evangelists and trainers from Intel today for you. So look forward for their sessions. And it's going to be a very, very learning activity for you because it's going to be a hands-on exercise. So don't forget to sign up to DevCloud. Be focused on the workshop contest. Share your results with me either by today before we close the workshop or latest by tomorrow 5 p.m. And log into Devmesh to submit your projects to be a part of this community. Thank you, and over to you, Lakshmi.
Thank you, Kavita. Can you all hear me okay?
Yeah.
Okay, all right. Very good morning, everybody. I just wanted to make sure I say hi to you, all of you, in whichever part of the country you are in. Very, very good morning. And I hope all of you are staying safe and staying healthy, and all your families are also keeping safe and healthy. And first of all, many, many thanks for willing to commit this next 3 hours of your work schedule. I hope you get the best out of it. This is the rough agenda we have for the next 2.5 to 3 hours. So what we will do is we will introduce you to OneAPI. Kavita did talk about OneAPI, and we will introduce you in more detail to what OneAPI is and what is the need of the hour. Why is OneAPI now? Right? We'll talk about that. And then we will set you up on DevCloud. I know many of you already have access to DevCloud. There are some basic setup related stuff that needs to be done before we just jump into the lab exercises. So what I will do is I will just make sure that I set you all up for DevCloud. And then what we will do is we will jump into the machine learning product overview, and followed by that, we will have a hands-on session. Right? So that would be the first half. The second half of the workshop is going to be focused on deep learning products and hands-on labs related to the deep learning products. Right. So approximately we would wind up by around 12:30. And please feel free to, if in case you're stuck at any point in time, feel free to ping us on Discord. There are folks who are trying to help you out on Discord in case you're stuck with the lab, in case you're stuck with any of the setup issues. We have people supporting on Discord. So please make sure that you are signed into Discord, and then sort out any issues that you may have in the process. So what we will do is we'll set you up and we'll give you some time for the labs. You can just do the labs in the specified amount of time. And in case you are not able to complete, it is absolutely fine. You have time until tomorrow, as Kavita said, for you to submit your results of the activities that you performed here. Right. So that is what this is the rough agenda for the next 2 to 3 hours. So moving on, I'll first introduce you to OneAPI. In today's complex world, as we are all fighting the pandemic, right, there are one set of researchers who are working on drug discovery and healthcare using image processing. Remote healthcare has become so famous in the last 1 year, right? Meaning India was trying to push this for a while, but I think this situation forced all of us to be in that mode naturally, right? And digital transformation, right? We were trying hard using techniques like demonetization and all of that to force digital currency into the country. But again, this pandemic has acted as a natural way to really force the digitization, right? And on the other side, all the consumer business or the food industry, right? McDonald's is trying to figure out, oh, what is my sale going to look like this Christmas season, right? Are people going to come out? Are people not going to come out, right? So how should I resource, right? And again, on the extreme side, the airline industry, how are they going to really resource? Are they going to have enough people fly through the year or the next year? So these are all the big uncertainties, and humongous number of researchers are working on these problems day in and day out using all these different compute platforms that we have today. If you probably take 10 years back, all of this, we can say, hey, our CPU can really do an awesome job with all these things, right? Different workloads, etc. But today, these different workloads demand actually different compute resources or different compute hardware. And the whole issue currently is that now when you have a code that runs on CPU and you move it to GPU, it doesn't really work, right? Again, you have to do a lot of work to port it onto a GPU or even an FPGA, right? So this is an ongoing experience, and I would say it's a frustrating experience for the developers. So what we wanted to do is unify all these challenges and make sure that we present a software layer, which is called OneAPI, which will address these issues of talking to all these different programming, different hardware devices, whether it is CPU, GPU, FPGAs, or any other accelerators. And this effort is what is called OneAPI. Multiple hardware, you have one set of layer talking to this, one set of software layer talking to this hardware, different hardware. Now, as an AI developer, probably many of you, 90% of you who are in this workshop today, may not be exposed to what is really happening underneath, right? How is your software really talking to the hardware, right? So in this workshop, what we aim to expose is, hey, when you double click, right, when you go into the next level, what is really TensorFlow doing, or what is some of these, the machine learning algorithms doing, and how is it really getting the performance out of the hardware that is underlying, right? So that is what we hope to achieve by the end of this workshop, and also make sure that you use these software tools and techniques to get the best performance out of your hardware with small changes that you can make to your code, right? So that is the whole objective. So now, how is OneAPI today? If you just Google for OneAPI, this is how you would be presented on Intel's website. You have the base toolkit, you have HPC toolkit, you have IoT toolkit, the OneAPI DL framework toolkit, the rendering toolkit, AI Analytics Toolkit. So there are all these different toolkits depending on the domain that you are focused on. So now, as an AI developer, what are all the toolkits that you may worry about? Or as let's say a data scientist or a researcher, what are the toolkits that you may have to worry about, right? That is what we will talk about here. So if you talk about the base toolkit, as we said, this base toolkit is kind of common for any workload, right? Some of these, right, like the compilers, like Python, probably today, if you probably ask any developer what is the meaning, if you just take a survey of what is the most common programming language that anybody uses, it is Python, right? So Intel, what we've done is we've taken the stock Python, optimized a lot of the packages to get the best out of Intel hardware. So base toolkit has some of the, I would say, base elements for programming, right? Whether it is compilers, libraries, all of these, when you use, you can just, today probably it is running best on CPUs, and you will see examples of that during the workshop, right? And eventually, for you, the interface would still be Python, the DAL libraries, DAL, we call it the DA1 data analytics library, we call it DAL, one DAL. The math kernel libraries, like if you're using packages like NumPy, SciPy, etc., all of these use the math kernel library, which are optimized libraries that are already running best on Intel hardware. Whether it is CPU, GPUs, any of these platforms, any of these hardware, these libraries are already optimized to run best, right? OneAPI, then from an AI standpoint, so what I have marked in red, these are the ones that are going to be very beneficial for from an AI standpoint. Right? So OneAPI CCL, or we call it the OneAPI Collective Communication Library, especially when you're doing training. We know that training is a massive compute, meaning it just takes so much compute. So how can we distribute? OneAPI Collective Communication Library helps you distribute the training workload across multiple nodes. And the OneAPI Deep Neural Network Library, this actually forms the backbone of all the optimizations that we have done to any of the frameworks, whether it is TensorFlow, whether it is PyTorch, whether it is MXNet, any of these, it will use the OneAPI Deep Neural Network Library to optimize their frameworks. So essentially, as a developer, as a data scientist, as a researcher, you don't have to really do anything with OneDNN. If you're a framework developer, like let's say you are developing TensorFlow, you are developing PyTorch, then you may need to worry about it. But if you're a developer, all that you do is you just continue to use TensorFlow. Underneath, we do all the magic for you, and you get the best performance. So this is just in nutshell base toolkit. From an AI standpoint, the ones marked in red are the key components that really get you the best performance. So moving on to the next file, I want to just talk about, focus on drill down now. We are just going to talk about the AI Analytics Toolkit, which is the focus of our workshop today. So if you look at AI Analytics Toolkit, as the name suggests, it is going to help you accelerate your machine learning, data analytics, and deep learning workloads. So if you look at deep learning, you can see that to the left of this chart, you can see that a lot of these Intel optimization for TensorFlow, Intel optimization for PyTorch, the Model Zoo, the low precision optimization tool, which essentially converts FP32 to int8 and any high precision to low precision models, right? So these are all the tools that basically leverage the base toolkit, leverage the OneDNN that we spoke about, and get you the best performance. So all that you have to do is you have your existing TensorFlow code, right? And then you replace that with Intel's TensorFlow code, literally very, very minimal code changes. You will also see what those code changes are going to be. You enable the one DNN, and then you get the optimized performance, right? So those small changes, how can it magically turn around your performance? What magic it is going to do? We will see that today, right? And on my machine learning side, we have the Intel optimized scikit-learn and XGBoost, which are also part of our Intel distribution of Python, right? It will basically help you get the best out of any of your machine learning workloads. And for data analytics, we know that the cleaning up of data and then the pre-processing, it involves a lot of, and loading the data, etc., takes a lot of time. So here is where Intel's distribution of Modin, a kind of replacement for Pandas, which really distributes even the data load, data preload, etc., onto multiple cores and multiple CPUs, right? And so these are some things that we will see in reality in using your hands-on labs. You will go through all of these today, right? In nutshell, you can see that what is happening is all the base toolkit you see here, it is all at the bottom. All the AI toolkits, what we saw, it is in the middle layer, and your applications pretty much at the application level, all of these are at the highest level, right? So if you were to just do it, all of these pretty much make the AI Analytics Toolkit, and then the base libraries, etc., which give you the performance, right? The Analytics Toolkit essentially uses the base toolkit components to really get the best performance. And then also we have the Intel distribution of OpenVINO Toolkit. It is primarily a toolkit for inference, right? So there is also this toolkit. We've had several workshops in the past which really talk about OpenVINO Toolkit. So this time we wanted to focus on the AI Analytics Toolkit, right? So in nutshell, this is what you get out of the AI Analytics Toolkit. And I wish you all good luck for the rest of the workshop. And I hope you were able to use these toolkits and get the best performance out of Intel hardware. So now, can we have the first poll, please? I see some. Is the poll open? Yes. Okay. So I'm just watching the progress live. I can see that around 80% of you already have access to DevCloud. That is fantastic. I think that makes my job easy. So let's just give a few more seconds. I see that only 73% of you have voted. If all of you can just click the poll. I don't know if you're trying to figure out where the voting button is. It should be on the dashboard. You should be able to see your polls. Please make sure that you vote. I can see 76% of you have voted, and 80% of you already have DevCloud access. Okay, are we done with the poll, Kavita? Are we still collecting the responses? I see around 80, close to 80% have voted. We are at 78.
Yeah, it will close in a minute, Alan. I think we are almost through.
I see. Okay.
Thanks. Yeah.
I think it's set to 2 minutes, maybe. I guess. Yeah, you can see it's. Okay. All right. Cool. I think that's great to know. 80% of you already have access to DevCloud. That's fantastic. But still, I just don't want to leave the 20% of you who don't have access. I'm sure probably I will just walk you through the process to get the DevCloud access real quickly. And then what we will do is for people who have DevCloud access, we need to set you up for some of the environment, etc. I will do that in parallel, right? So that's what I'm going to do. So let me just jump into the instructions. And please, there are also the DevCloud handbook is also pasted, is also pinned in your GoToWebinar. If you see the dashboard, you will see that it's already pinned. You can use those instructions, even though the same instructions I'm going to walk you through. The document will also be posted on Discord. So please go through that. I will just quickly make sure I move through this and then get to the environment, which is more important. Okay, all right. So the DevCloud access, it is one ONE in small letters. API is all capital letters. 17, and then J is caps. June 17 June, right? So please make sure API is all caps, and in June J is caps. Please make a note of it, and it is also given in the document. This is the DevCloud access code. So you have the enrollment form here. Please click on this link. Of course, right? Meaning I cannot click now, but yeah, of course, in your PDFs it should be a hyperlink. You can just click it, and the link is also available in the chat window. And click on register. And once you click on register, you will find that you are being asked for your first name, last name, your user, meaning using your email ID as the user ID for the login, etc. Just put in your phone numbers. Again, it's optional, and then your country, etc. And then you just click on the next step. And again, here there are a few more questions that you need to, the company, etc. Once you finish this, click on next. Click on next step. So I'm sure that you will receive an email from the Intel Developer Zone. Don't close the browser. Please make sure you have your email, and then you will have this login ID email address. So please verify your email address by clicking this link. Make sure that you are able to verify this by clicking this link, and then you're set. So it's a two-step process. We first give you access to our software portal, and then what we do is we give you access to the DevCloud. So that's how it is. So the current step that you're seeing is setting you up for our software portal, and then what we do is we sign you up for DevCloud. And once you click on the verify email, this should the browser gets refreshed, and it will lead you into the sign-in page, right? So sign up with your credential for the DevCloud registration page, right? So this is how you will get this page. So what you do is then you enter your details again, and then just click on submit. And please make sure you use this code OneAPI 17 June. Okay, I see if there are any attendees who have raised their hands, please, moderators, if you could just help them out, that would be great. Okay, so again,
Lakshmi, we have these handouts on the webinar as well as Discord. Folks can start joining Discord here.
Yes. If in case you have missed the setup instructions, etc., don't worry. We have the handouts attached in the GoToWebinar dashboard as well as Discord channel. So all that you do is just click on the DevCloud setup guide, and you will see the same instructions that are there, right? So you may not miss out on anything. Don't worry if you just didn't follow or if you just joined a few minutes back, right? So don't worry. We're just going through the DevCloud setup process, and I'm just walking you through these instructions for signing up for DevCloud. Okay, so now once you're done, you probably have you get a link. All that you do is just go to that link, click on the launch, go to the bottom of the page, this devcloud.intel.com, OneAPI get started. You will, if you scroll down to the bottom of the page, you will see that launch the Jupyter Lab, right? So you click on that, and then if you are using DevCloud for the first time, and you probably logged into it maybe a few days back, you will see that the server may not be running. So you click on launch server, and this will take you into DevCloud. So you should be here. Once you are able to start the server, it will kind of get you here. Okay, I am just going to give a minute or two for people to be here, because since 80% of you already have access, I'm not really going to wait here. You can always follow the instructions offline and get to sign up for DevCloud, and you can be here. So don't worry. So all that you do is just so I will just walk you through the next set of instructions that is there in the lab handbook. We are going to now switch to the setting up of the environment. As long as you have got to this screen of 8, the process 8, where you are able to see that welcome to Jupyter Notebooks, I think that's fantastic. Don't worry about step 9. If you are not there, I will anyway guide you through that. Okay. Okay, so now let me just switch to the I'm just switching to the AI Dev Cloud Handbook, the lab handbook. All that we are going to do now is we are going to set the environment now. So for some of you who are new to Jupyter Notebooks, these are some of the basics of Jupyter Notebook. You can just what here we have mentioned in the AI workshop doc. We have mentioned what each of these commands do and what is it. So now in terms of the first step, that what you have to do, you go to your Jupyter Notebook and then click on this plus button, right? And then you will get to the terminal, right? So that is something that I just want you to do first. Once you click on the terminal, you will get this, the terminals would be here. And then what you do is, the first thing that you're going to do is the git clone, right? So Aditya and maybe Mandar, if you can just paste this command also on the Discord, as well as the command on the Discord, as well as the GoToWebinar, I think that would be great. So all that you do is, we have a GitHub created for the workshop. So what we do is, you're just going to clone the content onto your local directory or your home directory. So that is what you're going to do. And this, again, these instructions are also provided in the handbook, the AI workshop handbook. The name is AI workshop doc. That's also pinned to GoToWebinar, as well as available on Discord. So for the first step is basically open a new terminal using the plus button that is here, and then you get to this terminal, and then the first thing that you do is do a git clone, right? So I have already done the git clone. So all the contents are already here for me. So I just want each one of you to just do a git clone. Right? Once you're done with the git clone, so what you do is you move all the content to your home directory from the folder, right? It would have created a folder called AI workshop in home. All that you do is just use this command to move the content from AI workshop to your home directory. So use the move command to move the contents of the AI workshop to your home directory. And now when you look at the home directory, when you click on this folder, right, if you are inside any of the subfolders, you click on this folder. Kavita, you're able to see my screen, right?
Yeah. Yes, sir.
Okay. All right. Okay. All right. So when you click on this folder button, it will take you to the home, right? You just click here. It will take you to your home screen, and there you have this thing called as Conda environment setup, env, Conda env setup. So let's double click that. And now what we are going to do is, this is very simple, right? So what is this doing? It is just setting a Conda environment for Intel's TensorFlow and stock TensorFlow. That is what we are trying to do now, right? We're not doing any magic. All that we're trying to do is, we're trying to create a separate Conda environment for Intel TensorFlow and stock TensorFlow, right? That's what we are trying to do now. So what you do is, go into each of these boxes. You can either press this play button, which means that you're running, or you can do a control enter inside the box, whichever is working for you. It is absolutely fine. So once you, when the time that you're running, there will be a star to the left of this, where you see the number here. You will see a star, which means that it is currently executing. Once it is over, you will see that a number appears here, right? So which means that the execution has completed, right? So what I want you to do is, do the same thing for each of the boxes in the same sequence, right? Don't miss any boxes. All that you do is just create the environment, just do a control enter, or you do a play button, right? So now you can see that it is done already. It's already 2 here, so that is great. So now what we are just going to do is, we are just going to do a cat on the setup environment, right? So this just to give you what we are doing, right? Essentially, it is just creating an environment, right? And then now what we are trying to do is, because it is a kind of a cloud environment, we are submitting the job to different nodes to do the job for you. So all that you do is step 4, you just do a control enter here. Please don't remove any dots, nothing, right? So just do a control enter or just do the play button and do it only once, right? Please do not do it twice. Just do it only once. And now when you do a Q stat, so Q stat is basically telling you whether the job has completed or not completed. When you do a Q stat, right, you will see that there is this setup env.sh that is running currently, right? So once this is complete, when you do a Q stat, this will disappear, right? So essentially we are checking whether if all the installation is complete for you, this setup env would disappear and you would have all the environment set up. So what we have done now, this setup is going to take quite an amount of time. It is going to take around 40 plus minutes. So don't worry. In the meantime, you would be covering the theory aspect of the labs, and then we will move on to this. And of course, this particular environment, we will only need it for the last deep learning lab. So don't worry. Even if it takes more time, it is absolutely fine. If you can just start the setting up the environment, and you should be good. Okay, so for you, don't close this notebook. Just make sure that you keep it open, and maybe once in a while, just do a control enter on QStat or just do a play on QStat. You will see that the setup env is still running, right? Which means that the job is not yet complete. So this may take a while. So just leave it there, right? If you're able to get to this point, I think we are good. And I can now, what I will do is I can now pass it on to our next presenter, who is Jing. Okay, any questions? Anything that before I move on, I just wanted to maybe take a few minutes just to answer any questions with respect to the setup or OneAPI. If we have any questions on Discord or on GoToMeeting, can we just let me know so that before I hand it over to Jing, I can address it. Mandar, Aditya, Jing, any questions on Discord? Kavita, any questions on GoToMeeting?
Yeah, nothing specific. We are kind of answering it here. Yeah.
Okay, all right. Okay. Yeah, thanks, Mandar. Kavita, anything from your side? Anybody has raised hands or something?
Yeah, I think we can do a quick hand raisers for everyone who are following the steps, maybe just to understand where they are.
So Kavita, is it possible that we can do a poll now to see if they have completed the setup? Just have you completed the setup, yes or no? Is it a possibility?
Yes. So Pradeep, do you think you can set this up quickly on GoToWebinar?
Sure, Kavita. Let me add the question right away.
Yes. Thank you.
That would be great. Thanks, Pradeep. So we're just going to give a quick poll to you just to check if you have completed your setup successfully. So let's see where you are. So I'm just giving a minute for the poll to come up, and okay, the poll is open. Okay, I can see the number going up. I can see almost 40+% of you have set it up. 50% voted. Can we have the rest of the people vote, please? I can see around 50% voted, and 43% of you are saying you have done the setup. You are where I am. Can we have more hands, please? More people, please? Okay, I can say 59, 60% of you have voted. Can the rest of you also please vote where you are? So don't worry if you're not there. Our folks would help you out in Discord and also you can follow the instructions offline as well. So 64% of you have voted, and 50% we are there. Okay, awesome. So 50% of you are saying that you have already with us in terms of the labs. So I think that's good to start with. So with this now, what I will do is I'm going to hand it over to Jing, who is our next presenter. Jing, over to you. I'm just going to make you the presenter now, and I think we're good. Thank you.
Okay. Yeah, thank you. Okay. Can you see my screen?
Yes, Jing, we can see it.
Okay. Yeah. So yeah, while waiting for the submitted workloads finish, let me introduce briefly about the machine learning products of Intel OneAPI AI Analytics Toolkit. So the first library that I would like to introduce is this OneDAO. As Lakshmi just introduced in overview of AI Analytics Toolkit, we have this Intel OneAPI Data Analytics Library. It is short for OneDAO. This library is designed specifically to speed up machine learning and analytics workloads. So it covers a wide range of workloads in machine learning field. It can do data pre-processing, like the decompression or the normalization of input data, or filtering your input data, and then it covers the functionality of the transformation, like do the PCA for the dimensionality reduction. Then we can do the analysis on the data. After that, the machine learning algorithms, the training or the parameter estimations, or the inference, not inference, the hypothesis testing or model errors, the validation stage can be covered, and the final step for some machine learning algorithms, like forest or the decision trees, we can do the decision making with the OneDAO. So this library optimizes the data ingestion and algorithm computation together for highest performance. And for small data set, it supports the offline usage. And if we are dealing with a extremely large data set, then we can choose to use streaming or use the distributed mode to do our work. Also, we can split the analytics workloads between the edge devices and cloud environments. So more detailed information can be found at software.intel.com/oneapi.OneDAO. Okay, so let's move to the next page. This is the structure of Intel OneDAO. At the lowest level, we have the CPU core kernels, we have the GPU kernels. We also use 1TBB as the backend for multi-threading. Also, as maybe you already know that in machine learning tasks, majority of the work, the calculation, is literally the mathematics calculation, like the linear algebra. So we use OneMKL. This is a library specifically to optimize the linear algebra computation on Intel architecture. It covers the optimization for matrix computation, for vector computation, as well as the matrix and vector computation. So we use this OneMKL as the backend to speed up this mathematics calculations. For the distributed multi-node calculation, we use OneCCL or Intel MPI as the backend to speed up the communications between the among multiple calculation nodes. So based on this fundamental libraries, we can divide the backends of OneDAO into CPU backend and GPU backend. So on GPU, OneDAO also has the optimal performance. Based on this backend, we optimize the performance for the several most widely used algorithms like k-means, like the PCA or random forest. So at the high level, we provide OneDAO interface for users to invoke our functionality in OneDAO. We provide C++ interface, which is part of OneAPI spec. And also we provide the Java bindings and Python bindings so that either the Python user or Java user can also benefit from our works. With the OneDAO, we optimized for the SkyKit Learn. We optimized for the Spark ML. Also, we optimized for the XGBoost. So users don't have to directly use OneDAO, but just use optimized version of scikit-learn, Spark ML, XGBoost, or Pandas, or NumPy. Then we will have the users can enjoy the performance boost. Okay, so the optimization that we have for scikit-learn is the at the low level. So from the high level user interface, there's no change to the scikit-learn API. So for the left side, if you have this scikit-learn source code, then if you install the Intel version, optimized version of scikit-learn, or if you install this DAO for Pi, then there are two methods that you can use to activate our optimization. One method is you need only this 2-line code change to your original scikit-learn code. Import the alpha pi and then run this patch underscore sklearn of this alpha pi. Then at the back end, it will initiate the Intel optimization. So the rest of the code will keep exactly the same as what you had. Another method is that you don't need to do any code change to your scikit-learn script, but use this alpha-pi module when you launch your script, like Python -m. -m means you will use this alpha-pi module of Python and then run your original scikit-learn script. So we can use exactly the same code, and thus we can have the same behavior of the scikit-learn. So it is scikit-learn API. It is not scikit-learn like. It is the scikit-learn itself, but we do some modifications, optimizations to the backend of scikit-learn. So exactly the same code, exactly the same behavior, but you will have different optimization. You will have the performance boost. Yeah, okay. As we just mentioned at the beginning, DAO for Pi, DAO has three methods of data loading and processing. So for the most commonly used one is the batch processing, which means we load all this data set together into memory and then we do the computation. So if we set an example, then we can choose this, the DAO for Pi dot k-means init. Then we initialize this k-means to have 10 centroids. The method is ++dens. If we are dealing with a great number of data sets, then we can use the distributed processing method. So literally, we can use multiple nodes to, we can split the data set into multiple nodes, and then we do the distributed one. The API calling method is also similar. So we will add one parameter, distributed equals true. Then the processing will be in the distributed way. Another scenario is that if we have the data input like a stream, like say we have some data today and we have some data yesterday, and also we will have data tomorrow. So in this case, we can use this online processing way. So the data will be streamed into this processing unit for processing. In this case, we will also set this streaming parameter into true. Then we will process in this online processing way. This is the performance demonstration of the scikit-learn. So we use the same code, but we achieve different performance. This is the experiments that we done on Intel Xeon Palladium 8276 CPU. We run multiple cases like k-means, fit, k-means, predict, PCA, or random forest, or SVC, or the linear reg, or KNN. The minimum performance boost we had was 3.6 times better performance. And the best performance boost that we had is the over 200 times better performance. So this shows that with Intel optimization at the back end, even we don't change the API invocation, we still can get performance boost. Also, this is the result to comparing the performance of scikit-learn workloads like k-means, PCA, linear regression, these different workloads on Intel platforms, on AMD ROM, on NVIDIA V100 graphics card. So the yellow bar shows the performance comparison that we have for the IDP, Intel distribution for Python, which is compared with ROM, AMD ROM. So if the number exceeds 1.0, exceeds this line, then it shows that AMD ROM has better performance than Intel platform. So from this results, from this graph, we can see that for all of these workloads, Intel platform has better performance compared to the AMD ROM. And similarly to this purple bar, if the bar is greater than 1.00, then this line, then it shows that NVIDIA V100 graphics cards has better performance than Intel platforms. Again, so all these experiments shows that Intel hardware has better performance than the NVIDIA V100 cards. So the software that we used for NVIDIA card is the Rapids CUML library. Okay, then we will show the scaling ability of OneDAL. So if we use only one core to do the workload, then it takes this amount of time. But if we double the core, we make the number of cores to 2, then the execution speed got half. And if we double the core number into 4, then the execution time also got halved. So from this graph, we can see that the core scaling performance of OneDAL is also good. So this follows the linear way. And also we have this curve. So the red curve shows that the ideal efficiency. The blue curve shows the actual efficiency. So we can see that even we use 56 cores, the efficiency is still greater than 90%. So it also shows that OneDAL has a very good efficiency for the core scaling. Okay, so let's move to the Jupyter Notebook, and Arithya will do this hands-on, help you guys to have some the feelings of Intel optimization for SkyKit Learn. So Arithya, let me make you as the presenter to do this hands-on.
Hello.
I can hear you. Yeah.
So we can hear you. Yes.
And also I can see your screen. Yeah.
Okay.
So Aditya,
but like till now that.
So Aditya, some of them were having trouble to navigate, where the plus button is, where the left-hand side panel is, etc. If you can just show, if you can just hide the panel, left-hand side panel, by just clicking on the view hide, and then just show them how to enable it and how to navigate to these notebooks, how to navigate to the terminal. I think that would be great before you just jump into the labs.
Okay, sure. I was just saying that that Conda setup will be still running for everyone. So shall we do it now, or because everyone will not be able to follow me?
Correct.
With
No. Yes, Aditya. So what I think some people are still struggling with the basics of Jupyter Notebook. So you can just show them how to find the terminal. So how to really navigate to the left-hand side panel, right? Some people are missing the left-hand side panel, right? How you can just enable it. You can just click on view and enable it, right? Just click on view. Can you click on view? Aditya, can you click on view on the top?
Oh, okay.
Yes. Yeah. If you just click on the view, you will see that there is a left-hand side pane. Just make sure you enable it, and then there is a plus button below the file, right? When you click on that, Aditya, can you just click on plus button? Yeah, and then you will find a terminal here. That is how you can open a terminal, right? And for those who have not yet the Conda setup, please note that that is for our next lab. So don't worry, it will still keep running. For the current lab, please focus on the current lab that we have. It does not have any dependencies. Arithya will just walk you through the labs. Okay, go ahead, Arithya.
Okay, sure, Helen. Thank you. So I think everyone will be having all these files, like census notebook, these two census notebooks, and yeah, like for this one, we need only these two notebooks. So let me like once again show you like the terminal. So on this plus click, you can see the terminal and open the terminal. And if you have not done the git cloning yet, you can do that from here. So like just paste the command which is in the doc, and then you move all the files to the home folder. So then after that, you should be seeing all these files. And for this hands-on, we'll be opening these two census notebooks. So I already have these open. And if your kernel is not selected, you can select. You can click on this kernel, or if something else is there, you can still click, and you can select this Python 3.7 one, and you can see this. So now we'll see like by using this OneDal library for scikit-learn applications, we can see like some kind of optimizations in our application of this census notebook. So let me run through all the cells and I'll explain like what's happening. So this one is basically downloading all the data. So it may take some time. That's why like I have already run it and I have this file. So this csv.gz file should be there in your home folder after running this cell. So I have already run this to save some time. And now, okay. Oh, sorry. So I forgot that you need to run first this one, census without OneDal. First we'll run this and then we'll go to this census with OneDal. So like download is like present in both of these. So you need to download only once. So yes, I already have the file. I'll skip that. And then here we'll import all the libraries required for this workload. So like NumPy, Pandas, and sklearn. So this is without OneDal. So this is like a normal import. So I have okay. This one. Now you should be able to run it. So when it's running, you can see this star. I think I need to. So when it's running, you will see some star here in between the square brackets. Then okay. So again, sorry, some more imports need to do. So this one from sklearn, we are like getting this module for like splitting the data set in train and test set. And then like we are importing the linear models available in sklearn. So we'll be using ridge regression. So so we are just importing them. Then it will like this command will form the data frame from our data set which we have. It will take some time, so we have to wait for this one. So if you see that when you are clicking this note cell, and if it's not showing the star like this, then you can also use this run button. Like click on this and then like click on this run button, or you can directly use control enter. So that's what like do. So it will take some time. Okay. So meanwhile, like we can see, like if you have any questions running these notebooks or anything about these, you can see
Can
questions.
you be closer to the mic, please? Your voice is not very audible to the audience. Thank you.
Okay, Kavita. Yes. So I can see like if you have any questions because it's still learning.
You can tell them approximately how much time it may take so that they can do it at their pace as well, right? So in case they are stuck, it would be good to.
Ideally, like it takes 1 or 2 minutes, but I'm saying like it's taking more like, right now. And before the workshop, also like I checked, it's taking some more time.
Yeah, that's okay. That's okay. Let them do it, and it's okay.
Or
And maybe,
shall I show?
yeah, if you want to just show them the other one also, the $1 one, you can just explain the code, right? Without executing, you can just explain the code, and you can just tell what's happening.
Okay. So after when we have the data frame ready for this data set, we'll be like cleaning the data and make it in the form of X and Y to train. So these are all the like columns available in this data set. So these are like features for our model, and then we'll like clean this up by removing some unnecessary data and like which will not be required for the training. So we'll clean it up, and there is some kind of normalization happening for this income. This is also needed for this one, and uh, then like we'll convert our income which will be the output in y, and then x is our input for the model. So it will we will remove these two columns, income one and this the one which is required for normalization. So we have removed all these, and now we'll be having the features removing the income which we want to credit for our model. So now we have prepared the X and Y for data set for the model, and so here we'll do the training. Let me check again. So right now, just we are just waiting for this to complete. Meanwhile, like if you have any questions till now, we can see. You can post it in the chat window. Okay.
So maybe any of you, meaning we can just check if any of you of them have been able to complete one of the notebooks, right? The without one doll. Let's just check. I think yours got completed, Arithya, now. Looks like did it get completed now?
Yes. For me,
Okay.
like now the data frame is ready to be used. Now this is the cleaning features. It will also take some time, but not this much. So so
So
here
maybe
in this hmm?
yeah. Go ahead. Go ahead, Ajit. Sorry.
So in this notebook, what we are trying to do is we are predicting the income from the features like here. So we have the data set from 1970 to 2010, and with these features, we want to predict the income for the next years. So that's what we are trying to do. This is using the linear regression. So like it's with some regularization. It's called ridge regression. So we are using this ridge regression algorithm to predict the income from all the features. And so we have like prepared the data set. Uh, so in y-axis, what we are going to predict is income, and we have removed this income from X because it was having in full data set also, and remove this also because this is used for normalization. So now we have this X and Y ready. Okay, this is completed now. Now we can run the training for this model. Let me run this. It will take some time. Then I'll walk you through this. Okay, so I have put it on. It's running now. So okay, so here this is the one we imported linear model 2. So we imported this from sklearn, and now we are taking our model as ridge regression, and these are like mean square error values and coefficient of determination values. These will be useful for accuracy and all errors. These are like some parameters to set, uh, and random state is like to make sure that we are getting different data set every time in every run. So okay, so we have created this numpy array from this x and y for x and y, and for each run we are splitting our data set into like 90:10 part for 90 for training and then 10 for testing. So here we are doing that only, and we are setting this random state different for each run so that we don't get like same data set like again. So we want like kind of different data set for each run. That's why we are using this random state. Uh, so it will take some more time. It will take around more than 5 minutes. And with this, with the model we got ridge regression, we can just fit our model like this, and it will predict predict the y values, income values for the data set we have for testing, and then like we can do all calculate the mean square error and coefficient of determination like this. So we are checking the time required for all this training and comparing this with the Vandal. So this one is without Vandal scikit-learn, and in the other notebook we will see whole of this training for scikit-learn with Vandal optimization. Okay. So anything like any questions till now? If you have any question, you can post in the chat.
That they have some errors coming and all that. So just maybe you can just reiterate how they choose the kernel, etc. Because I think it could be something related to them choosing the right kernel, etc. Right? Just make sure they choose the right kernel and run one box after the other. Right? Even if they skip one box, they may have it may throw an error. So just guide them to choose the right kernel, as well as just making sure they go box by box. Right?
Okay.
So you can just show them how to choose the kernel, Python kernel, and also just
Yeah.
make it.
Yeah. So like for kernel, just we need to just click on this one, and you will see like many kernels. You can select this Python 3.7 Intel OneAPI. So this is the kernel we need for these notebooks. About the error, I'm not sure. Like maybe.
Yeah. Yeah. If you can quickly check the Discord, you may probably I think it is. Yeah.
Oh, okay. Maybe like make sure that you have run all these else.
Yes.
If
That's what I.
you would have missed this sklearn import, may have caused some.
Yeah, I know some of the boxes are a little small, so there is a natural tendency that you may have missed it. Just please make sure that you go box by box, hit Control Enter or hit the play button to make sure you run the cell and then move to the next step. So Nag, if you're there, just make sure that you reopen the notebook and then just go cell by cell. I think this error is mostly because you have missed a particular cell, right? So that's what it is. It looks like. I know Deepika was also stuck with something. So Deepika, are you sorted or are you still having issues? So if any of you are stuck anywhere, just make sure that you put the screenshot out there. If your server is starting up, etc., it may take a few minutes because there is also a good load on the system. So please wait for a few minutes. It will log you in. In case you still have issues, let us know.
So how much time do we have, Alan? Like for this?
So this maybe Aditya, another 5 minutes. You can just try to wrap it up.
Okay. So because it may take like more time. I've seen like yesterday and today it's very slow. Like that cloud is.
Yeah, it is possible because of the load also, Kavita. Yeah, that's okay. So you can just show them how to do, and they can do it even through the day. They can just do it, and they can send the results to us. So you can just show them how to do it. So please be a little
So
patient.
I have
There may be
run.
cases where the dev cloud could be a little slow because of the load. So, but I'm sure you should be able to log in. So in the meantime, Aditya, if we want to cover modern theory and then just come back here, that is also okay, right? Let these boxes keep running. And then if you want to just have Jing cover modern and then come back, that's also okay. So we have time till 11:20 for the ML part. ML part. So
Hmm. Or should I run this on my local machine?
No, yeah, you can just show them. Yeah, that's also okay. That is
Let's
also
wait
okay.
for
That's also okay.
this one. Because here it's faster.
Yeah, you can just show them on the local machine.
Okay,
The
like so
notebooks are
same
local.
instructions. Mhm. So here just don't be confused because of this kernel. So this is like same kernel with Intel Python. Over there, the Python was in OneAPI. So that was also Intel Python. Here it's a with different name. So I have already run this cells just before this. Um, so with this one, after running this cell, it will show like how much time did it take for the training of this ridge regression model, and it's showing like 353 for this census notebook without one dal, and you'll see like all the like errors and deviations here. Okay. These can be like checked later also. So, and then when we move to this census with one dal, uh, just the same things you need to do. These things are same, and only thing we have changed here is just as Zing explained in his slides that we need to do this dal for pi import, and with that we need to import the sklearn. So only this line is added, newly added for activating the one dal's optimization for sklearn. And now once it's started, it will like use one dal optimizations for all the for this notebook. So we can check again here. Oh, it will still running. So again, when I ran this for one dal, or maybe I can. So when I ran this for one dal, we will see like same steps are there. This is one. This is the one which get the data frame from the data set, and these are the same data cleaning and data preparation features. Then then we have the same instructions for training also, like getting the ridge regression from this linear model. Now this linear model has been changed because of our optimization using dal for pi. So this LM, so this LM is now coming from this dal for pi scalar. So that's where like the optimization is coming from, and so everything is same, like number of runs is same, train size, and these random state. And after running this, you can see like it will be like fairly like a very small value than the one with without dal. And then again the same values you will see, like there will be no difference in the accuracy or error values. You can check this errors we got pretty high for both of these. And then like we'll store the values. Okay, I don't need to run it again. So here like this is the comparison for time required, time taken for the training of both ridge regression from one dal and ridge regression from like normal sklearn. So time taken for sklearn without dal for pi is like much higher than this one with dal for pi, and you can see the speed up here. We are getting almost 6 times of speed up for this one for the ridge regression training. And yeah, like you can also see this kind of speed up in on Dev Cloud. So it will take some time. So I think I can give the control back to Zing to show the modin related theory. So I think
Okay, I think iTech had.
Or if you have any questions or doubts, you can post.
I can see that there is one person who has completed the labs. That's amazing, and he could see the results as well. We can see it on Discord. So maybe what we can do is, Pradeep, can we have the poll to just see how people are doing with this lab? Maybe you can just post a poll of if they have completed this exercise.
Sure, Alan. I'm just launching it.
Yeah. So we're just launching a quick poll just to check how you're doing. Have you completed the lab one, right? So feel free, meaning even if you say no, there is no problem, we will help you out. You know, it should be fine. Don't worry. I see only 39% have voted. Feel free to vote. Based on that, we will know how to, you know, how fast we should go or how. Okay, see 33% is a yes out of the 54% voted. 68% still a no. So don't worry, we will give you the time. You have all the time. You can, you know, you can do it. We will anyway. What we will just do is we will just cover some theory aspects and we'll give you some additional time along with the, you know. So 62% have voted, 63% and 70% says no. Okay, so I just want to repeat some of the instructions. Make sure you have not missed any of the small boxes. If you miss any of them, it is likely that you may get an error in the next step, right? If you are getting an error in any of these steps, please make sure that if you have missed any of the boxes, executing any of the boxes, right? So that would be great. I think, Pradeep, yeah, we can close the poll now. I can see almost like around 30% have completed, 70% still have not completed. Yes, we will, don't worry, right? We will give you some time towards the end so that we can do all the labs together, right? Maybe we can now have Jing talk about Modin, and we'll followed by a small demo, and then we will give some time. Jing,
Yeah,
over to you.
Yeah, sure. Good, yeah.
Okay, Jing, sorry, I need to give it the control now.
Yes. So you can transfer the control to Jing.
So where is that option? Okay.
Okay, yeah. This is my screen?
Yes.
Okay, yeah. So while we're waiting for the execution to finish, so let me continue to introduce the Modin interdistribution of Modin. So it is very natural that to do the machine learning work, we have to load data, and generally speaking, the more data you have, the higher accuracy that would be, the result would be. So along with the increase of quantity of the data size, loading data in a high efficient way is becomes a topic. So for the we have several most widely used tools or libraries that are used for this data loading. One of the most famous one is Pandas. Is this Pandas? And another one is the Spark. So Pandas fits more to the scenario that we use. So Pandas is a little bit, easy to use. The API is not difficult, but the scalability of Pandas is hard. In the opposite, Spark, it has very good functionality for the scalability, for scaling, but it is not easy to use. So we have this kind of problem. One is good, easy to use, but not able to, very hard to scale. One is good at scaling, but not easy to use. So we introduced the Modin to be a optimized tool, which can deal with a great number of data size, and it is easy to use, and it can be very easy to scale to a large amount of simultaneous data loading processes. So this is what we do in Modin. Originally, we use this import pandas as PD to use pandas API to do the data loading. But if we have Modin, then we can change this clause into import modin.pandas as PD. So we just replace the backend of pandas into Modin. So from the latest version of Modin, it supports 100% of pandas API. So it is very easy to. It is competitive to to the rest of Python, ecosystem. Like the libraries use NumPy, use XGBoost, use the SkyKit learn. In the backend of Modin, we use the it is supported by OmniSky, shown here. The backend is supported by OmniSky. It is a performance framework for end-to-end analytics that has been optimized to harness the computing power of existing and emerging Intel hardware. So the reason why we can have higher efficiency with Modin is that for pandas, if we run pandas on big machine with a large amount of data set, no matter how many available CPU cores you have, pandas will always use only one core to do the data loading. So this is very not in high, not efficient way. So with Modin, it will automatically detect all the available CPU cores that on your machine and use all of them to do the data loading. So like in this case, originally we use one core, but if we change to Modin, then we can have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30 times better performance than single core loading. So this is the reason why we have better performance with Modin.
Jing, we're not able to hear you.
System level API like Fusion API, Storage API, Data Frame Algebra API, Query Compiler API. And based on this system level API, it provides user level API. But since the dice that I just introduced, it is 100% compatible to pandas. So you don't have to invoke Modin API by yourself, but just use pandas API. This is the performance of data loading workload of the NYC taxi. So NYC taxi is a data set consists of New York City taxi data. We split this into two separate experiments. The results, the higher the better. So we demonstrate the performance boost with a smaller size of data set. So this is a sub data set. The yellow bar is the speed up of pandas. So it is 1. All of these performance data are normalized to fit this pandas as the baseline. So the yellow one is the 1. The speed up number of Modin plus OmniSky is shown as the blue bar. So we can say that for some data set, it is almost double the speed of pandas. For some of the subdata set, it increased to almost 18 times better performance than the pandas for this small size of data. If we run the data loading on an extremely large amount of data, which shows here is 1 billion rows, if we convert it to memory, then it takes 1.6 TB. So by comparing the performance of loading all this data with pandas and with Modin plus Omni, we can see that the minimum performance boost was 10 times better performance. The maximum increased to over 90 times better performance. So this is a very huge speed up. So yeah, let's move the screen back to Arithya. He will have a demo to show the performance of Modin.
Okay.
Yeah, it's your screen, Arithya.
Thank you, Jing. Okay, can you see my screen?
Yeah, we can see.
Okay.
Arithya,
So
I cannot hear you. Are you
census,
muted?
Yeah, we can
no,
hear him. We
Jing,
can...
I have not spoken yet. Okay. So for this census notebook also, there is something I need to tell that maybe you would be like getting a mean square error like too much. I think if you put the education in place of income, that would be for that you will not be getting this much of error, because I think notebook is originally for calculating the education. So that's something I wanted to tell. Otherwise, we are only comparing the time. So for that, there is no issue. Only you would be getting like too much of error just because of some small change we have made. And if you put the education here in y-axis, you would be getting very small errors, and you can make this change if you want.
So Aditya, some of them were getting an error,
So
I think,
for,
with plotting the graph. So just for plotting the graph, you have to have run both the census with DAL and without DAL for you to get the graph properly. If you have run only one, then you will not see the graph. You may see some errors, right? So you have to run all the cells before that. You have to have the mean and standard deviation for both. And then when you run this graph, the last few steps, the results comparison, that will run only if you have run both the notebooks, right? The previous step from both the notebooks. That's something that I just wanted to highlight.
yes, before doing this training with DAL, you have to do it with without DAL also. So we have to run all these with without DAL, and then move to the one with DAL, and then you'll be able to get the results, because we are storing this time from no DAL notebook, and then we are plotting graph. So yeah. Moving to modern demo. So for modern demo, like we'll not be able to like show the demo on Dev Cloud, and also everyone cannot do this because there is some issue on Dev Cloud with modem. So unfortunately, I have to like show it on my local machine as a demo. So for demo for modem, it's just like pandas. You don't have to do anything. So I have all this set up. Let me change the kernel to Python 3 is also fine, I think. So Python 3 is also Intel Python. So let me show like what it gives. So these are like so we'll be showing like small operations in on data frames, which Panda also does with comparing them to model. So like we are importing these numpy and for plotting matplotlib, and then to compare the time, importing time. Then we are importing this pandas as like as nothing, just it will be pandas to differentiate with it with modern pandas, and we'll import the modern pandas as PD. So whenever we'll use PD in using the data frame, it's using modern. That's what it is. And here we are generating some synthetic data using NumPy. So like we are generating random integers, and we'll store them in CSV file. So this here it's no use of any pandas or model. We are just creating the NumPy array. Okay, so we have created the array and saved into this foo.csv. And now with pandas, so this is where we are using pandas, original stock pandas, and we'll read the CSV with this and create the data frame. So let's see how much time it takes. So yeah, with pandas, it took like 13.2 seconds to create the data frame from the CSV. And now we'll do the same operation with PD. Like PD is for modern pandas. So we'll do the same thing, create the data frame. And you can see like it happened very quickly in 2 seconds, and it took the pandas took stock pandas took 13.2 seconds. So yeah, like we can see direct speed up here, and to show the visualization of this speed up and calculation, we can see in this plot. So approximately like 6.5 something we are getting here. It's showing like something else, but yeah, like we can see that time for the panda is 16 seconds, and time for modern is like 2. So we are seeing like almost 7x of speed up, 7 or 8. And then we'll see some other operations with data frame and their speed up. So let me run this. So this is like calculating the mean for axis 0 means we are calculating the means for every column in our data frame. So with stock pandas, it took 4 seconds, and with modern, it took like 0.5 seconds. So again, similar kind of speed up. You can see 7.28 times of speed up with modern. And then again, some other functions like applying some function on each column and row. So we are doing this apply map, and we are just increasing the value of all the columns and rows by one with this function, and we'll see the speed up again. So this is with pandas. So basically, this pandas df is the data frame which we created using pandas, and modern df is the one we created with modern. So like both are what will run differently, and then yeah, like this one is completed, and now we'll see with pandas same operation with modern, and we can see like it's very quick in comparison to the one with pandas. So that's why like you're seeing this 85x of speed up. So so you can see like this kind of speed up with functions applying, and for many other functions we are just showing one of them. And then this is the concatenation of two data frames. So again with pandas we are doing here. And we'll do it stock modern. So with just one click, like it's completed. We can see the speed up of 68 times. So this is what like modern can do, like your data interpretation or your data operations, which these can be done very quickly with modern, because it's using all the codes as Jing explained. And these are some examples, like all the functions which are used in pandas can be used with the modern also. So like this filter, and then counting number of rows or columns. All the like these functions uh, can be done with this modern data frame which we created with modern. So, yeah, this is just to show that everything which you can do with pandas, it can be done with modern also, with just one line of yes, Ellen.
Yeah, quick time check, Aditya. We are kind of running out of time for the next one. So
Okay.
So I think there is also a lot of demand.
Done.
Yeah, there is also a lot of demand for this notebook. So maybe what you can do is you can just post this notebook, even though I made it clear that we cannot run it on DevCloud. So people want to try it on their local machines. So maybe you can just post the link, or you can upload the notebook to the GitLab and give the link so that people can download, and of course they can use it in their environment. And I just want to reiterate for the contest or even Devmesh, feel free to submit these projects that you have gained, right? Meaning, because I'm sure many of you here are using pandas. It's just a small simple change that you do and you get like 60-70x, right? So we would love to see some of your projects posted on Devmesh with these. So Aditya will share this notebook on GitHub. You can download it, and then you can customize it in your code and see how it benefits you folks.
Where I'll share where yes,
you can share it in the same GitHub
okay.
where you posted, Aditya.
Okay, I will share there.
Yes, and you can share the link in the to us on Discord so that people can download it.
Okay, I'll share with the phone instructions to set up this AI model also, like, because it requires some kind of setup.
Sure. Thanks, Aditya. Okay, Jing, over to you for the. Yeah, and maybe can we have the quick, quick poll, please, Pradeep.
Sure, Alan. The poll question will be on libraries used for optimizing ML workloads, right?
Yes.
Okay.
Should we continue now or wait for the poll?
Yeah, Jing, let's just wait for the poll to complete and we will start.
Yeah, okay.
Okay, we can see only 36% voted. Can we have more people participating, please? 40% voted. I think we may need a little bit more number of people, please, to vote. 44. I see many of them are saying 1MKL and 40, almost 8. And okay, I should not tell the number of people. Okay. Okay. All right. Okay, we have 50+% of people who have voted. Okay, I think we can close the poll now.
Okay.
So Aditya, you want to disclose the answer? Or Jing, you want to disclose the answer? Go ahead.
Aditya will disclose the answer.
Go ahead. Yeah. Aditya, please go ahead. Go ahead, Jing. No problem.
Oh, okay. Yeah. So just now we learned something about the traditional machine learning products.
So Jing, do you want to disclose the answer before you move on to deep learning? The people are all waiting to know what's the answer for the poll.
Oh, I don't see the answer of the poll.
Okay, so no. You can just tell what the answer is, the actual answer.
So answer of which question?
So which one of the following libraries are used to optimize machine learning workloads, right? So the answer is 1MKL, 1TBB, none of them, both of them.
Yeah, the answer is both of them.
Yes. Sure, thanks. Yeah, you can go ahead. Oh, yeah.
Okay. Yeah. So just now we learned something about the traditional machine learning products. So from this slide, we will introduce about we'll introduce the deep learning products in OneAPI. This is the deep learning Intel deep learning software stack. Let's again starting from the low level end. So at the bottom is the Intel hardware, CPU or GPU. We use Intel 1MKL and 1DNN to optimize for the deep learning frameworks. Because the reason we use 1MKL is that there will be a massive computation of linear algebra computations like GEM, the matrix multiplication, or the vector matrix multiplication, and these operators are specifically optimized in 1MKL. Another one is that 1DNN. 1DNN is an open source Intel architecture optimized deep learning library for scalable high velocity integration with machine learning and deep learning frameworks. So most of the most popular deep learning operators like convolution pooling are optimized in 1DNN. So we use both of these two libraries to optimize for the deep learning frameworks like TensorFlow, PyTorch, MXNet, or Caffe, or Chainer, or PaddlePaddle. So overview of 1DNN is that the 1DNN is a highly vectorized and threaded building blocks. So it optimized for critical deep learning critical functions, like shown in this table. It optimized for the 2D, 3D convolution, deconvolution, different kinds of, different types of convolution, as well as the inner product, so the matrix multiplication. Also, it optimized for pooling, like max pooling, average pooling, as well as for the normalization, like LRN normalization, the batch normalization. The activation functions are also optimized, like ReLU, tangent H, PReLU, and as well as the softmax, or logistic, or linear square, these mathematics functions. Also, there are some data manipulation normalization followed by ReLU. MKDN fuses these patterns into one single operator, which raises the performance. For the data set that 1DNN support, if we are doing training, then we support the float 32, bfloat 16. For inference work, we support the float 32 and int 8. 1DNN is very compatible to multiple compilers, including the Intel C++ compiler, the CLAN, GCC, or MSVC. And also it works on operating systems like the Windows, Linux, Mac OS. By default, it uses OpenMP as the threading library. Also, it can use TBB as the threading library. So there are three major methodologies that we used to optimize these operators in 1DNN. The first one is the vectorization and the parallelization. With these techniques, we can use the instruction set, the power of instruction set, with the highest efficiency. The second one is the memory layout consideration. We use a SIMD, so Intel architecture friendly memory layout. And the last method is to fuse some commonly used patterns. So this is the one example of how 1DNN optimize with the vectorization. As we know that for the traditional compilation technique, So what does this do is in runtime, it will detect which hardware platform it runs on first. So if
Jing,
it yeah.
Jing, I think your voice was breaking in between. Maybe you may just want to repeat this file because we lost at least a few seconds, or maybe around 30 plus seconds. So I think it's breaking
Okay.
a little bit in between. Yeah. If you
Okay.
can just maybe repeat this file, that would be great.
Okay. Yeah. So this is an example. My voice now is good, right?
Yes, we can hear you now. Yeah.
Okay. So this file shows that an example of how OneDNN optimizes its performance with the vectorization. Traditionally, when we compile a source code into binary, when the binary is generated, the optimization has been fixed. So if we compile a source code for AVX2 instruction set, then it should have a better best performance on AVX2 machines. But on AVX 512, it will not fully use the CPU power. So to deal with this problem, to solve this problem, OneDNN used a technique called the dynamic assembly, which means that once the OneDNN binary is running on a platform, it will first detect what instruction set this platform supports. If it is an AVX2 device, then OneDNN will generate the code which is optimal to AVX2 in runtime at the beginning of the running. So the exactly same code, if you run it on AVX 512 machines, then at the beginning of the runtime, OneDNN will generate the AVX 512 optimal code. By using this method, it is very flexible to providing the best performance on a variety of devices. Another method that we use to optimize OneDNN is the memory layout. So considering from since the TensorFlow and the PyTorch, they have to consider multiple various of types of hardware devices that the code will be running on. So for the default data layout, they choose either NCHW or NHWC. But neither of these two, NCHW or NHWC, is the most friendly to Intel architecture. So in OneDNN, we have our own, which is called the seamed friendly blocked layout. So like this NCHW16C. There are a lot of a series of these blocked layouts to adapt multiple input data sizes or the structures. So this will automatically be handled by OneDNN. By using this data layout, we can fully maximize our users CPU efficiency on Intel hardware. So OneDNN will also handle the data layout conversion through this reorder operator. And the third method is called the fusion one. So originally we have the convolution, ReLU, batch norm, which are the native operator of TensorFlow or PyTorch. But since we optimize convolution in OneDNN to increase the performance, we can simply replace this original convolution into the one we optimized in OneDNN. So this convolution is generally much faster than this gray convolution. But since we introduced in this page, there is a data layout conversion. So we have to do data reorder first and then do the convolution, then reorder back and then call the native ReLU or batch norm. So this would be faster than original code. And once we enable more operators in 1DNN, then we can replace all of them into the one that we optimized in 1DNN. Because all of these operators are 1DNN operators, so we only have to do reorder at the beginning and do reorder at the end. So this will be faster than this naive integration. But after all, these three primitives are three independent primitives. So the memory overhead between two operators is inevitable. To reduce this overhead, we fuse this most commonly used patterns into one single operator. With this method, with this fusion method, we can increase the performance further. Okay, so Aditya, will we have quiz here? Yeah, I will hand this over to you.
Okay, thank you, Jing. So can we show the quiz, Kavita? Next quiz. Okay, so I think. So the question was like, which of the operations are optimized by a 1DNN library? So that was the question. Options are like CNN operations, and activation and loss functions, and RNN operations. So which of these are, or all of them? So which of these are optimized by this 1DNN for all the frameworks, AI frameworks? Okay, so still people are voting. So 44% of all have voted.
We have about 53% people who have voted.
Yeah, you can close the poll. Yes.
Okay.
Okay. So yeah, we can see like 6% of people have given that CNN operations are only supported, and some people are have given that answer that only RNN operations are supported, and so but almost like everyone has 90% of them have given the correct answer, I think. So all of these operations are optimized by 1DNN library. So I can quickly show the slide also, which in which like Jing explained this. So
Aditya, before we just move on, maybe we'll just give a 5-minute break. I know we haven't had a break since 9:30. Maybe if any of you want to just take a quick 5-minute break and then come back, what we will do is we will quickly go through some of the the optimizations for TensorFlow, and then we will have the lab. Maybe we'll do a 5-10 minute intro of the optimizations for TensorFlow, and then we will jump into the labs. That's the most interesting part. So I hope all of you are able to we also did the environment setup, etc., for the Intel TensorFlow, etc. I hope by now it should be complete. Maybe we'll just take a quick break. We will exactly start back at 11:50 Indian Standard Time. 11:50.
Yeah, just an announcement. Sorry, just an announcement to everyone. I think you guys are doing very great. I've been receiving some great results on my email, but would request you to just wait for the final labs to close, and then you can send me your performance results to screenshot either by today or by tomorrow 5 p.m. Thank you, guys. Let's take a quick break. Thanks, Helen.
Thanks, Kavita. Yeah, that would be great. Yeah, I know. So we have so many enthusiastic people who already sent the screenshots. I think the next would be even more interesting for you folks. So the next screenshots, let's see how many of you are able to are able to do those, and then get back to us with the results. It's very interesting. Thank you. Thanks for being so engaging.
Okay, regarding the answers, so we can see that all the operations, be it a convolution or any like these machine learning related loss functions, normalization. So all these are optimized by 1DNN. You can see RNN also. So answer will be like all of them.
Thanks, Arithya.
Ellen, there is a question from Ajay on Discord. If you could please help address that.
Sure. Let me just, okay, these $1 are open source term license. What is the support model on cloud? So I think it's a very valid question. So from Ajay, let me just address it here only. So the question from Ajay is $1 and one DNN, right? I think you meant 1DNN or open sourced or licensed. So $1, so they are not. I think 1DNN is open source, but $1 is not open source. But they are available free of cost. You can download from Intel website. They are available if you download the Intel OneAPI based toolkit. Both $1 and 1DNN are available, and you can use it on cloud. You can use it on your private on-prem machines, etc. And you just have to adhere to the end user license agreement for distribution, etc. But other than that, these are just free libraries that you can use for your workloads, for your AI algorithms, etc. They are absolutely free of cost.
Ellen, can you repeat it after a couple of minutes, because many people might have gone for a break, right? So yeah, if you can repeat it.
Sure.
Yeah.
Sure.
Thank you.
So I'm just also like the support model as well. I think the support model is we have free community support. You can go to community.intel.com and then you can choose. If you have any issues, you can always submit issues, and we'll be more than happy to help you out.
If Kavita, if you want to show something else in the break, you can show like on the screen.
Yeah, if you can just, Ellen, perhaps focus on the Devmesh slide.
Okay, Devmesh, Aditya, you are sharing your screen?
Oh, yes.
Yeah, you can go ahead and share. The Devmesh slide you can share. It is the third or fourth point.
Okay.
Can we remove the poll? I think the poll is still on my screen at least. Or maybe you're sharing the screen. Yeah. Okay.
Yeah, Pradeep, can you close the poll?
Aditya, I think you are sharing your screen where now we are seeing the poll question, right? So you can just maybe you can just move to the file. Okay, anyway, I think we are we're at 11:50. Let's get started, Aditya. Let's get started on the foils.
Okay.
We are only seeing the poll on your screen, so please make sure you move to the foil, and then we can get into the labs.
Poll.
Or is it my screen? Okay, let me just, yeah, I think, yeah, we are seeing the
No, I
poll
can
screen.
also see the poll. Yeah.
So how do we how do I remove that? Because I'm sharing my screen. Okay.
Yeah, I think we are good now. You can present again.
Yeah, you can go ahead, go to the foil.
Okay.
So,
Okay,
Aditya,
so,
before you begin, Aditya, I just wanted to just let people know there was a question on how to use OneDAL and related components. So, just wanted to let you know that OneDAL and OneDNN. They're all part of the Intel-based toolkit. These can be downloaded free of cost and can be used in your projects, even production. So, feel free to download the OneAPI-based toolkit to get access to OneDAL or even the Intel distribution for Python, where all the optimized packages like scikit-learn, etc. It is available. And also these are available in different channels, right? Like Conda, Pip. It's also available across all these different channels, popular repos. So you can also download it from there. From a support standpoint, we provide support for all of these through community.intel.com. So we have a community support where there are engineers who are looking at it and providing support as required. Right. So I just wanted to repeat that before Aditya begins. So Aditya, over to you. We can move fast on the deep learning part.
Okay. So till now, we have seen machine learning optimizations by Intel's MKLD, one MKL or one DNN, and one DAL. So for them also, we can submit a project on Devmesh. So because it's very easy to make a model or using this and compare on Dev Cloud. So for machine learning, it's really easy. And for deep learning also, we'll see you can check the performance and use the Intel's optimizations and share the projects on Devmesh. Okay, so I'll start with Intel optimization for TensorFlow. So are you able to see my screen, Alan?
Yes, Aditya. Yes. You can go ahead. We can see your screen.
Okay, so we'll see. So till now, we have seen optimizations using 1DN under the hood of all these frameworks. So most of the operations which most of the optimizations we'll be talking here for TensorFlow, they'll be in sync with 1DNN because 1DNN is the one which is doing all these optimizations. So we'll start with operator optimization. This one we also saw in 1DNN. So basically TensorFlow is a graph which contains neural networks, neural network nodes, and then there is some kind of flow of data or tensors from input to output. So we can represent a network using this kind of graph, data flow graph. Then so with TensorFlow also, all these operations which 1DNN supports and optimizes, all are supported here. So we can see that our normal convolution 2D, which can be replaced with 1DNN's MKL conv 2D. So it will be replaced automatically by the optimization. So we can see there are so many operations here also. So all the these operations are same. So these are mainly okay. These are mainly convolution and pooling norm, but it also includes all the RNN and other operations also. So these are the operations which are automatically optimized by 1DNN. So this is kind of operator optimization. And then when we use this optimization, we can see like for each operation, the time taken by these operations will be like reduced. So let's see, let's take an example. So let's say this is without any optimization from 1DNN. So we can see that for this convert 2D operation, it took like 640 milliseconds, and when this operator optimization is used, so the name is changed because MKL is added. So the same operation convert 2D is now MKL 2D, convert 2D, and here we can see like it took 391 seconds. So this kind of operator optimization it gives, like for each operation it reduces some time as a optimization. So for most of the operations you can see, so since this is a ResNet model, image classification model, we are seeing mostly convolution based operations, but it also applies to other operations like RNN based models and other normalize and activation function. So all the operations are optimized. So then moving to next optimization is the graph optimization. So it basically, so here basically, so the idea is, so the lesser the number of nodes we have, it will be like flow will be faster. So so we want to reduce the nodes, number of nodes, and keeping the flow same. So here this fusion is used. So basically, when some operations can be added to a single node, it is done here. So like here, convert 2D and bias addition is done, and then and bias is also added here. So these three operations are merged or fused. It will reduce the it will reduce some time for this. So this kind of operation is also optimization is also there. Then this is the another example. Uh, and then when we have the our operators replaced by the optimized operators, we need to like add some kind of layout or conversion of normal tensors before doing that. Even after doing that, this addition using these optimized operations is still a better option. Even though these convert operations are taking some time, still these are so well optimized that it can overcome this conversion time also. So this layout propagation is basically when we have like two convert operations in the line. If let's say there are 2-3 MKL operations in a series, and we can see this these two convert are not necessary because these two operations are 1DNN's optimized operations, so they don't need any kind of conversion. So this is kind of a layout propagation optimization. And then like till now we have seen all the optimizations within the TensorFlow. So when we download the TensorFlow, Intel optimization of TensorFlow, we see all these optimizations under the hood. And now for us, like the manual optimizations which we can do according to our system, these are like these are the operations we these are the optimizations we'll see. So once we get our model, now we want to like optimize it for our system. So here comes the picture of using multiple cores and using the operation using multiple threads. So here we'll see like these OpenMP related parameters can be set, and we can utilize all the cores here. So with this interop parallelism threads, so it basically it basically tells that how many operators you can execute in parallel. So this we can set, and then this interop of parallelism thread, it shows like for one operation into how many threads we can divide it and use it. So it also depends on our system number of cores. So and open OMP num threads is basically the same thing which we used for our Intel optimized TensorFlow. These two operations are basically for all the for other TensorFlow also, stock TensorFlow also, but with MKL DNN we use this OMP num thread. So in our code, TensorFlow code, we can use these threads and put our get the performance better. And for different configurations, we have to set these number of parallelism threads different value. So okay. And one more thing is like when we are like we cannot set like these values to anything like any value. So let's say like we have 24 cores, and we want to put this intra of parallelism thread 24, then it may not be possible that it will give the better performance, because for different workload and different operations, uh, it can go up to like it can give different parallelism. So sometimes it may give over subscription, like it may take more time in switching the context and all. So that may lead to over subscription and give the even worse performance. So we need to set this intra parallelism accordingly. Like we need to check with different values. So that's what this system optimization is. So these include like all these OMP related settings. Once you install the Intel TensorFlow, you can put all these environment variables with different values. Some recommended values are given on our this link, but still like you have to manually set these values according to the workload and system configurations. So this one, okay, so these are all the same things, like these are all OpenMP related settings which you can check on this link. It will show like for which kind of workload recommendation values are these. So okay, so system. Okay. Okay, so let's talk about OpenVINO. So now like we have talked about this TensorFlow. So TensorFlow can be Intel optimization for TensorFlow can be used for both training and inference. So in both of the cases, we can see speed up. And let me show something. So as we can see in this one, in this table, so we can see like for forward operations, these are like optimized, and also for backward operation, these are optimized. So these backward operations will be used for training purpose. So we can say that this 1DNN and TensorFlow will optimize or will give the better performance for training and inference both. And when it comes to inference, we have a different toolkit, which is again optimized for real world inference of AI models. So this OpenVINO stands for basically Open Visual Inferencing Neural Network Optimization. So this initially it was optimized for visual inference models only, but now it's like it's also added the support for other models like RNN based models or recommendation systems based model. So nowadays it supports all kind of models. So basically in open, what happens is it takes so there are like 3 steps in it. So it basically takes models which are pre-trained using any of these frameworks. So any framework we can use like TensorFlow, Caffe, PyTorch, Onyx. So for PyTorch, like we have to convert that model to Onyx, then only we can use the OpenVINO toolkit, and it's very easy to do that. So we get our model in any of these frameworks, and like OpenVINO, it converts our models to representation, which is intermediate representation. So it basically converts this optimization, these models with some kind of optimizations it has. So some of these optimizations are like fusion, which we saw in TensorFlow also. So one of the optimization is that, and then it converts to our this intermediate representation, which is now framework agnostic format. So we'll be having this XML file and bin file in IR. So this XML will be having the neural network of our model, and bin file will be having all the weights and biases. So now we have converted this our framework our models in any of these frameworks to a framework agnostic format. Now this can be like used to do the inferencing on any of the hardwares. So here comes the inference engine, which uses all these libraries or plugins. So for CPU plugin, MKL will be helping it to give the better performance on CPUs, and for others also, like there are different libraries. Like for GPU, there's one CL, OpenCL library, and then yeah, so it can be uh, deployed on any of the hardwares using this intermediate representation, which is now like not dependent on framework. So it basically like optimizes in terms of like making the inference faster. So that's what the OpenVINO is. Mm,
Okay, Aditya,
okay.
quick time check.
And
Quick time check, Aditya.
and one more thing okay. So for this OpenVINO, we have like already like pre-optimized models available on the Open Model Zoo. It has like all the models, like for all the use cases, it has some models, and those can be used like as a starting point. So okay, so let's have the quiz time.
So Aditya, in the
So
interest
can we
of
show
time,
the quiz?
Aditya, in the interest of time, let's skip the quiz and let's jump into the labs. We have only 20 more minutes. I just want to give people time to do the hands-on. So let's just jump into the labs, and then we will, if time permits, we will see what we can probably have the quiz at the end. You can move on to the labs.
Okay. Not able to. Okay.
So one thing is maybe now what people can do is just we have to go back to that Conda environment and now check their Q stats if it is done, and hopefully it should be done by now. And now you can start with this new lab. Yeah, go ahead, Aditya.
Okay. So I think if your Conda environments setup has been done, you can move to this exercise. And for that, like you can
Aditya,
open this.
Yeah, Aditya, I think
Yes.
we may want to just show them how to check whether the environment setup is done or not, right? So it would be good to just show how to do that, how to
Okay.
check if it is done.
So after that setup, I think let me open this setup notebook. So if you see something like this, like when you have run this command, so if you see like only one job, then like your other job which was running has finished the all the setups. So I think that's one of the signs that you have done with your setups. And other than that, like after the setup, you will be able to see these two kernels, Intel TensorFlow and Stock TensorFlow. So these two kernels should be visible after you have done the installations or setup using the notebook. So I think most of you can would have done that. So let's move on to like cloning and all these steps required for this exercise. So in exercise 2, we are seeing that this we need to git clone this thing. We need to get all the required notebooks and profiling tools in our local directory. So we'll do the git cloning. So you can copy this link, and in terminal we can open terminal again. So in terminal we can do this. Okay. So you can git clone this models. So it will create one folder here, models, which we'll see after cloning. So it has created the folder.
And maybe I think this would be common for most of you. At 71%, it may slow down a little bit. So don't worry. Meaning when you're doing a git clone, exactly at around 71-72%, it may slow down a little bit. So don't worry about it. It just takes a few more minutes. That's it.
Okay, I think I should have done this earlier.
So I think the rest of them anyway can just follow the instructions given in the document, and Aditya will do it in parallel, right? So feel free to just follow the instructions, and we'll do it in parallel.
Yes, like if your this cloning is completed, you can like follow these instructions.
And the process is still the same, right? Once you open the specific notebook, all that you do is you set the kernel first, like what we set for Python 3.7 for the previous time. You have to set it for Intel TensorFlow and stock TensorFlow, right, separately, and then you run each of the boxes, right? So that's how it works. So Aditya, if you want me to share my screen, I can probably do that, if yours is not yet done.
Oh, okay. I'll also do it in parallel.
No, you can do it in parallel. Let me just check quickly. So let me just show it. You can give control to me. I can just show it. Okay, can you all see my screen? So once you have done the cloning successfully, in your home directory you will see this folder called models. So inside that models you will have this benchmarks. Okay, sorry. It is
Models and docs.
docs. Sorry. Models, docs, and then notebooks and perf analysis, right? And then you have this. Once you navigate to this folder, you will see that there is a benchmark comparison.ipynb, right? So what you do is you double click this, and this is the notebook that would open up. And here the default would be Python 3.7, right? First, what you do is you change that to stock TensorFlow, right? So you just change it to stock TensorFlow and then execute all of these boxes, right? Just one after the other. You can just execute these boxes. And once you're done with one, you just change the environment to Intel TensorFlow and do the same thing. So only the running the benchmark, this may take some time, right? The rest of them would probably be much faster, right? And then you will have like you'll have a screen like this, and then you will find that, okay, there is something like this you will get after you run both the stock and Intel TensorFlow. So the key thing is you have to change the environment or the kernel here on the top right to Intel TensorFlow, meaning first do stock TensorFlow and then do Intel TensorFlow. So first use stock, run all the cells, then repeat the same with Intel TensorFlow. Choose Intel TensorFlow here, and then select. You will see that on the top right, it will be Intel TensorFlow. Just repeat the same process. Yeah, Aditya. Yeah, I don't know if yours is done. If you want to explain any of the code, I can go into any of. Yeah.
Yes. Give me the control.
You can. With... Okay, all right. I'm just giving you control. If you have any questions, you can post it on.
So I'm in this folder, performance analysis, which I think Alan explained and given here also. Like in models, you'll see docs and then notebooks and performance analysis. So you'll see these 4 notebooks. So we have to open this performance benchmark perf comparison Python notebook. So, and make sure, one more thing I need to tell that in this running kernels and sessions, make sure that you shut down other kernels like this. Only like kernel running should be the one with this benchmark of comparison. So for me, it's now the only one. Okay, so let's run with in stock TensorFlow. I'm selecting stock TensorFlow. So this notebook is basically to show all the like operation level time difference in with Intel TensorFlow and stock TensorFlow. So it's basically more of a like profiling all the operations in both the models, in both the frameworks. And you can see like in other notebook, this tensor benchmark of timeline notebook, the detailed comparison will be given. So let me run this first. So it's ignoring the warnings. Here we are like creating all the profiling folders. Let me run this. So this one will show like configurations of our system which we got on that cloud, and accordingly we can set like all the OpenMP threads and other settings in later cells. So yes, it's giving all these details. Now here we are checking like which TensorFlow version we have, and for stock, so one thing to notice is like for stock TensorFlow, you'll be seeing this MKL enabled false. Since it's on Intel TensorFlow only, you'll be seeing this false for stock TensorFlow. And then here we are seeing the supported topologies for this notebook to show the comparison. There are many more topologies supported, but here on this notebook, this GitHub page, it's not there, but you can do it accordingly. So we have these four topologies to check. So I'll be selecting like I'm selecting one, let's say. You can select 0 or 1. Like I'm selecting this ResNet 51 version 1.5. So let me select it, and and also like here we are doing inference, not training. So that's one thing to know. Okay. And here like we are getting the ResNet 50 model and all the like required files. So to download the pre-trained model and then data set to run this inference. So it may take some time because it's downloading it.
So I think some of them are having issues. So Rahul, make sure that you have the first thing is make sure that you have run the Conda setup, the environment setup, and that is complete, right? Only after you complete that, you come to this notebook for running the Intel TensorFlow stock TensorFlow benchmark, right? If you're getting this error, make sure that you are actually executing the previous previous cells properly. Just re-ensure that you are not missing any cells. Hold on, I'll change the kernel to stock.
Okay.
Okay, Aditya, I think I'm just watching the time. Right, we are at 12:25, so I think we should probably, what we can do is we can be available on Discord for people to just help people out. Maybe we can quickly, you can just show them how the output looks like, and maybe we can they can run it even after they can continue to work on it. We can help them through the Discord channel even after we end this meeting. I think we can always help them out over the Discord channel, but I'm just a little sensitive to the time. I know many of them may have other commitments as well. So, maybe should we just show them how it will look like?
Yes. So yeah, you can share your screen, but let me just show something. So in this step 3, you are like mainly running this like all the inference and storing this in files to see the comparison. So this is the main cell which will be taking some time in step 3. So you have to wait for like some time for this one. So Alan, now you can share your screen since you have already run this.
Sure. So okay. Okay, can you see my screen? So once you have run all of these, both, so what you do is you can see that there are 3 sections in the notebook, right? You have to run section 1 and 2 on different kernels. First, run using the stock TensorFlow. What you do is you just repeat all of this step until the section 3, right? Repeat that, and again change the kernel, and then repeat the same set of steps. And once you're done with both, then you come to section 3 and execute this, right? These boxes. Then you will see that you can see that, okay, how much throughput you get with the stock TensorFlow, how much throughput you get with Intel TensorFlow. So this is how you will see. And especially when you're sending the results, I would really appreciate if you could share these screenshots along with your results, right? That would be great. I think that's what would really be helpful, right? So when you're sending the results to Kavita, make sure you send these screenshots as well, right? How much scaling you're getting with both stock TensorFlow and Intel TensorFlow along with the numbers. Okay, so I repeat the instructions. Section 1 and 2, you do it using different kernels, Intel TensorFlow, stock TensorFlow, and then you come back to section 3 after running it for both the kernels, and then you compare the results. That's how it is. Okay, all right, so this is how it will look like. And you can continue to work on it. And I just want to quickly also summarize and a few concluding thoughts from my side before, So just to summarize, I think today what we did was we introduced you to OneAPI, different components of OneAPI, and we then double clicked on the AI piece of it. So we spoke about the AI toolkit. And if you are so this file basically summarizes if you are a native code developer or a framework developer, what would be most useful for you, right? As a native framework developer, when I mean framework developer, if you are a TensorFlow or a PyTorch developer, for you, 1DN and 1CCL would be the most beneficial for you. If you're a data scientist and an AI researcher or MLDL developers, from a classical ML standpoint, you will use for data ingestion, you will use Modern and Omnisign, Pandas, NumPy, SciPy, etc. And then if you are probably using for classical ML training, you can use scikit-learn, Dalphi, and XGBoost. And now, if you are on the DL side, deep learning side, you can use the Intel optimized. You can use the AI kit, and especially the Intel optimized TensorFlow, PyTorch. It can be used for training, retraining, and also for inference. And let's say you already have a pre-trained model that you want to use. You can also use OpenVINO and then deploy it using any of the hardware. Right. This is just a quick summary. If you are a developer, if you are a framework developer, if you are just an application developer or a computer vision developer, right? This is how AI toolkit and relevant Intel toolkits may be beneficial for you, right? So what I just want to summarize is that I think AI Analytics Toolkit is one of the best toolkits for framework developers, anybody, right? You're an AI researcher, developer, data scientist, anybody. So you can make the best use of it and get the best use of it out of hardware, right? So today, just imagine we just only saw performance on CPUs alone. When you are using these frameworks and toolkit, it can scale to any hardware, right? GPU, VPUs, and FPGAs, and any accelerators, right? So that is what I just wanted to highlight. That is the advantage of using OneAPI and relevant toolkits, right? So I just want to summarize. Thank you so much. There will be some surveys sent to you. I think it will be in the Discord channel for giving us feedback on what we can make it better. I know we were a little time crunched, but the idea is for you to even continue the work after we are done with the workshop. You can continue to do the TensorFlow stuff, and then you can share the results with us. If you're stuck there, please post it on Discord. We will continue to help you out through the day so that you are able to get the results that you want, right? So even though the meeting ends now, the Discord channel will be open. You can continue to post your questions. If you're stuck with any issues, we will be able to help you out, and we can make sure that you get the results that you wanted. Okay, so that's what I just wanted to let you know. So thank you so much for taking 3 hours of your time, and really appreciate it, and urge you all to participate in the contest and also submit your projects on Devmesh so that we can showcase you and your work in different forums. Maybe when we are conducting a workshop like this next time, you can be presenting your application and your story, right? So that is the whole intent of this contest, and as well as the Devmesh projects. So thank you so much, and over to you, Kavita, if you wanted to just add anything.
Yeah, thanks. Thank you, Ellen and team, for that fantastic training and presentation. And I'm sure the developers who present here today would have had some great takeaways. And the Discord channel is always open for each one of you to come back and ask us any relevant questions you might have. Now, there are two things I just want to reiterate, and Ellen just touched upon it, Lakshmi just touched upon it, the Devmesh project. The modules you have learned today from the workshop, if they works for you on your existing, applications which you have been running, if you want to relook into the OneAPI components, go back and share your projects on devmesh.intel.com. And don't forget to send me the link of those projects before 25th of this month, and you're eligible for the contest to win some amazing prizes there. The second contest is on the workshop, which is open till 5 p.m. tomorrow. If you didn't get a chance to work on DevCloud today, post the workshop, please sign up again and submit those performance results to me, kavita.arur@intel.com, and then be in touch with us on Discord if you have any questions or queries on the same. So thank you, and I think now over to Sujiti. I would like to thank the AIM team as well for organizing such a wonderful event, and then for gathering the right audience to amplify the OneAPI message. Over to you, Sujiti.
Yeah, thank you, Kavita. Thank you. That was a great session. It was Lakshmi very well portrayed Jing and Arithya. So thank you, Kavita, once again for doing this wonderful session for our attendees and give us an insight on the OneAPI AI Analytics Toolkit. Now data scientists can leverage this productive, cost-effective architecture to accelerate their performance. Before we end the session, I will quickly like to announce the 15 lucky winners of Intel DevCloud pre-registration contest. Each one of them are going to receive Amazon vouchers worth ₹1,000. So I will quickly name those 15 winners. So Kaushik Ghosh, Mahesh Bhai Chauhan, Suresh Reddy, Prashanta Kunda, Kondinya Bhogaraju, Lakshmi Varanasi, Abhilash C, Prasad Pawar, Ajay Gupta, Vamsi Krishna, Shivam Bhatt, Ashutosh Ranjan, Yatindra Panchal, and Shaktikala Palani Swami. So congratulations to all of you. The winners will receive their prizes over email by Analytics India magazine. So on that note, I would just like to remind you guys that there are two contests that's going on. One is the workshop contest that's going to end before 5 p.m. tomorrow. So please mail your entries to kavita.arur@intel.com. And please also participate in the Devmesh contest, which is going to run till 25th June. We are shortly sharing the survey link on the chat box. So please share your survey for the event, for the session. How was it for you? So that's it. Thank you once again, Kavita, Lakshmi, Jing, Arithya. It was a great session. And that would be a wrap for today. Thank you.